Hi students, welcome to my YouTube channel, and in today's video we are going to learn about base. But before base we are going to learn about basic oxides. Basic oxides is the oxides that contains the ion O2 minus. You know what is oxide? Oxide always have O2 minus, and in my previous video of acid I have told there what is acidic oxide. I hope you remember, and if not then please go through the video and then come here. And now basic oxides contains the ions O2 minus and reacts with an acid to form salt and water only. Okay, alkali metals, alkaline earth metals. I have told you that alkali metals are from group 1 while alkaline earth metals are from group 2, and transition metals generally form basic oxides. Because as their metallic character is high, that is why their electron donating tendency is very much high. And basic character, that means to donate electron, is high over here. That is why these alkali metals, alkaline earth metals, or some transition metals, they form basic oxides. So let's have an example of Fe2O3. This is iron oxide, and when it is treated with 3H2SO4 or aqueous solution of sulfuric acid, then it will produce Fe2SO4 ferric sulfate, and then, or you can say iron sulfate, and also produce water. So it is actually producing here, this is basic oxide, and in presence of acid, when it reacts with acid, it produces one salt and water. Another characteristics of basic oxide is when it combines with H2O, it forms base. Previously I have told you that acidic oxide, for example CO2, when it combines with H2O, it produces H2CO3, carbonic acid. Remember, I have told you in my earlier video. And here, when basic oxides such as Na2O, it may be MgO or K2O. So then Na2O, when react with or combine with H2O, it forms base. It produces base here, 2NaOH. So that I have told you that why metallic character or basic character depends on metallic character of, that is why the alkali metals, alkaline earth metals, they produce basic oxides. If we go down from along a group, we will find that the metallic character is gradually increasing, and thus electron donating tendency is increasing and ionization potential is getting reduced. Thus basic character is increasing, and thus they form strong basic oxides. But if we move left to right along a period, we will find that as their metallic character is gradually decreasing, and thus their electron donating tendency is reducing, and as this electron donating tendency is reducing, on the other side electron accepting tendency is gradually increasing, and thus ionization potential is getting higher, and thus basic character is reduced, and thus for this reason most non-metallic elements, they produce acidic oxides. So that's about acidic oxides and basic oxides. So one thing, there is another kind of oxides is also present, that is amphoteric oxide. Amphoteric oxide is just between your basic oxide and acidic oxide. They react both like base and acidic oxide. Okay, so they react with both acid and base and produce salt and water. Previously I have told you that basic oxide, when reacts with acid, it produces salt and water. Similarly, when acidic oxides reacts with base, it produces salt and water. But here amphoteric oxides are those oxides that react with both acid and base, and they produce salt and water. For example, here Al2O3. So Al2O3 when react with 6HCl, hydrochloric acid, then it will produce AlCl3, aluminum chloride, and 3H2. Others type of amphoteric oxides is ZnO, PbO2. You can see that most of the non-metals are in this case. Here zinc, lead, both are non-metals. That is why they produce amphoteric oxide. So that's all about amphoteric oxides. So there is another thing, why lead oxide, PbO2, is it's not in basic oxide. You know, basic oxide, in basic oxide there is one thing is very important, that it contains the ions O2 minus and reacts with an acid to form salt and water only. Because when basic oxides main character is that when it reacts with an acid, it will only produce salt and water. Another product cannot be produced here. But here you can see PbO2 is a metallic oxide, but when it reacts with an acid, it produces a salt, PbCl2, lead chloride, 2H2, salt and water. But here chlorine gas is also produced. It is a metallic oxide, but it's not a basic oxide, as it is producing Cl2, chlorine gas. Next, move on to basic hydroxide. So it contains OH minus and reacts with acid to give salt and water only. For example, NaOH, when react with HCl acid, it produces NaCl salt and H2. Now, what is alkali? Alkalis are the basic hydroxide that dissolves in water and produces hydroxyl ions. Hydroxyl ions are this ion, OH minus, is called as hydroxyl ions. And as they are basic hydroxide that dissolves in water and produces hydroxyl ions as the only negatively charged ions. So, we read that basic oxide when react with acid to give salt and water, but alkalis are those basic oxides that dissolve in water. It means that those basic oxides that do not dissolve in water are not alkalis. Similarly, you can say that KOH, CaOH whole to NH4OH, they all are alkalis. But alkalis as well as basic hydroxide, as they all dissolves in water. But there are other basic hydroxides also, like FeOH whole 3, ferric hydroxide, you can say, copper hydroxide, COH whole 2. They are basic hydroxides, but they don't dissolve in water. That is why they are not alkali. So we can conclude that all alkalis are bases, but all bases are not alkalis. Even asked that explain why all alkalis are bases, but all bases are not alkali. So then you can write this there. Now, what is base? So after reading about basic oxides, amphoteric oxides, acidic oxides, basic hydroxide, alkalis, now we are going to learn about bases. So a base is either a metallic oxide or a metallic hydroxide or ammonium hydroxide which reacts with hydrogen ions of an acid to form salt and water. Always remember that what I have told you just about basic oxides, basic hydroxides, they both can be bases, and their only properties is that they have to react with the hydronium ions, H2O plus ions of acid, and they will produce salt and water. So these two factors is very much important, that they react with hydronium ions of acid and produce salt and water. Now let's learn the classification of bases or alkalis. Actually, it can be classified into two categories, based on their strength and based on their acidity. So what is strength? Actually, strength is associated with the dissociation process. So if there is complete dissociation in ions within the aqueous solution, then it will be strong alkali. For example, NaOH, KOH, okay, sodium hydroxide, potassium hydroxide, they are strong alkali because they dissociate completely in aqueous solution and it produces high concentration of OH minus. Again, weak alkali are those generally dissociate partially in aqueous solution. For example, your NH4OH, CaH whole 2, calcium hydroxide, ammonium hydroxide, they are partially dissociate in aqueous solution and thus they are weak alkali because they produce low concentration of hydroxyl ions. Now, based on the acidity, actually previously I have told you about basicity of an acid in my previous video about acid, and this is here you will see that what is the acidity of a base. So it is the number of hydroxyl ions produced per molecule of the base, and previously in basicity it was the hydronium ions produced per molecule of the acid. So what is monoacetic base? So monoacetic base are those bases that produce only one hydroxyl ions. For example, your NaOH, KOH, NH4OH, if they dissociate in aqueous medium, they will produce Na plus plus OH minus. Similarly, K plus plus OH minus. That means that they are producing only one hydroxyl ions. That is why they are monoacetic base. Again, diacetic base. So this is calcium hydroxide, copper hydroxide. So when calcium hydroxide dissociate, it dissociate in this way. It produces one calcium ions of 2 plus oxidation number and two hydroxyl ions. Thus, they are diacetic base. Similarly, AlOH3, aluminum hydroxide, when they dissociate in this way, it produced one Al plus 3 ion and 3 OH minus or hydroxyl ion, and thus they are triacetic acid. So, this is about the classification of alkalis or bases. So, for a quick recap, you have to remember what is basic oxide, that it when reacts with an acid, it produces salt and water only. What is basic hydroxide? When it reacts with an acid, it gives only salt and water, and it contains hydroxyl ion. What is alkalis? That alkali is a base soluble in water. Alkalis are those basic hydroxides which when dissolved in water produces only hydroxyl ions as the only negatively charged ions. That is about alkalis. What is the difference between alkalis and basic hydroxide? That all alkalis are bases, but all bases are not alkalis. You have to remember what is soluble basic oxide, soluble basic hydroxide. For example, your ferric hydroxide FeOH3 and COH2 cupric hydroxide are bases, but they are insoluble in water. That is why they are actually insoluble basic hydroxide. Again, you have to remember that sodium hydroxide NaOH or caustic soda, potassium hydroxide KOH or caustic potash are highly dissociated in aqueous solutions, and that is why they are strong alkalis, while NH4OH, ammonium hydroxide or calcium hydroxide, CaOH2, calcium hydroxide can also called as slaked lime. So they dissociate partially in aqueous solution, so they are weak alkali. What is acidity of a base? What is monoacetic acid? Their examples: diacetic acid, example; triacetic base, example. What is amphoteric oxides? What are the examples of amphoteric oxides? So you have to remember all the things for the short questions that may come in your exam paper. Now, actually there are several factors behind the solubility of NaOH and insolubility of FeOH3. For your class 10 syllabus, you have to just remember NaOH is soluble or not, while FeOH3 is soluble or not. So this is you have to remember, but I can say simply that because of their structure mainly they are soluble or insoluble. NaOH, you can say that it's very simple structure and has only one hydroxyl ion, but the structure of FeOH3 where Fe3 plus ion is surrounded by 3 OH minus ion. That is why when water molecules comes to dissociate or break the FeOH bond, you have to work very hard because there are 3 hydroxyl ions surrounds Fe3 plus. That is why it has to work hard, and for this reason FeOH3 is highly insoluble in water. Now let's learn some physical properties of bases. Actually, they are of sharp and bitter taste. They are soapy substances. Okay, and they are strong electrolytes, conduct electricity. I have told that they easily dissociate. Some of the alkalis like NaOH, KOH, they easily dissociate in aqueous solution. And as they easily dissociate, they produce ions, cations, anions in aqueous solution, and thus where there is ion, there will be electricity. That is why it conducts electricity. Okay, and they are mildly corrosive. If we use excessive soap that contains very much bases, alkalis, then it will dry our skin. That is why it is mildly corrosive. It can only dry out our skin. Now it also changes the color of the indicator. For example, litmus. It turns litmus papers from red to blue, methyl orange, orange to yellow, in basic medium, methyl orange become yellow. Now let's learn about some chemical properties of bases. If you keep base in open air, it absorbs CO2 from air and thus produce salt and water. So for example, NaOH, it is a strong alkali, and it thus absorbs CO2 from air and produce Na2CO3, sodium carbonate, and H2O, water. Is neutralized acid that I have already told you that when acid reacts with base, it produces one salt and water. Next, when we add base to the solutions of salts like CuSO4, and we are putting the base over here is ammonium hydroxide, we'll see that it precipitate a salt and insoluble metallic hydroxides, CuOH2, that is the copper hydroxide, and its color become pale blue. Actually, CuSO4 in aqueous solution is blue in color, and when it reacts with NH4OH, it produces CuOH2 or precipitate as CuOH2, which is pale blue in color. Now, if we heat alkali with ammonium chloride salt or ammonium salt, ammonia gas, pungent smell of ammonia gas emits. Now, let's learn the preparation of bases, how we will prepare bases. Sodium metal, when treated with oxygen, it is producing a metal basic oxide Na2O. And the next thing, by the action of water on reactive metals like sodium, potassium, calcium, in this case they produce a base Na. Here you can see when we react Na with 2H2 water, it will produce 2NaOH and base and hydrogen gas. This is very much important as it is producing hydrogen gas. And this reaction I have told you earlier in basic oxide. Remember, I have told you that there is a characteristic of basic oxide about when basic oxide is treated with H2, it gives base. Now, action of O2 on metal sulfides. So, there is a metal sulfide ZNS, zinc sulfate. So, when we heat ZNS with oxygen, it produced ZNO, one basic oxide, and sulfur dioxide gas is thus emitted. Now, decomposition of salts. For example, there is a salt calcium carbonate, and when we heated it and we produce CaO and CO2 gas is emitted. CaO is calcium oxide and it is a basic oxide. And here you can see ZnNO3 zinc nitrate, when heated it produces ZnO, metallic basic oxide, and NO2 nitrogen dioxide gas and O2 gas. So this is the decomposition of salts where you will get basic oxide with a gas. Here it may be CO2 or it may be NO2 nitrogen dioxide gas. It is of brown color and oxygen. Okay, so double decomposition is the process when aqueous solution of salts is treated with base or alkali, it precipitates the respective metallic hydroxide. For example, FeCl3, it is the aqueous solution, and when it treated with NaOH base, it is producing FeOH3 ferric hydroxide, and the color of ferric hydroxide is orange or brown orange. Okay, and it's also producing a salt. It is soluble in water, NaCl, sodium chloride. And the last thing, that ammonium hydroxide is itself a base. I have told you that is a weak alkali. So when ammonium hydroxide can be prepared by simply dissolving ammonia gas in H2, because ammonia gas is highly dissolvable in water. We have learned that the physical properties of base and then chemical properties of bases. So you have to remember these four reactions. And also remember the preparation of bases. For example, this is important as we are producing basic oxide, base over here. So these are important. So you have to remember all the things. So one thing I give you as your homework, that you have to read the general uses of some bases from your book. So I hope guys you enjoy the session. If you have any doubts, any queries, any question that you feel that it is not going to be solved by you, then you can go directly to the comment section, ask me. I will give answers of this question as soon as possible, and in my next video I will pick some important questions from acid and bases and try to solve them in front of you so that the idea become more clear to you. And if you like the video, don't forget to like, share and subscribe. Thank you for watching.